we know SAS congruence, remember? So before getting started with Hinge theorem, we have a quick revision about what we did with SAS congruency. See, two triangles will be there, ABC and DEF. Okay, in that SAS congruency, if you need to apply, means the corresponding sides, two sides should be equal. Okay, and the included angle should be equal. Then we call that as Hinge theorem. Sorry, SAS congruency, right? Simply, instead of this two angle, included angle is equal. Suppose if they are not equal, if A and D are not equal means what is the possibility? Any one thing will be greater than the other, right? Okay, so in two triangles ABC and triangle DEF, okay, the corresponding sides, two sides are equal and the included angle are greater. Like this angle 1 is greater than angle 2, suppose. Okay, and we have these sides AB is equals to DE and AC is equals to DF. When everything holds, the Hinge theorem that states that then the side opposite to the angle 1 BC will be greater than the side opposite to angle 2, that is EF. That is what the Hinge theorem states. Okay, and then similarly it is like SAS congruency rule that we earlier know. If the angles are not equal, we need to compare them, and based on the comparison, the opposite sides also will compare. That is it. That is what Hinge theorem. And then the converse is there. Conversely, suppose in these two triangles, in triangle ABC and triangle DEF, we have the sides AB that is equals to DE and the side AC that is equals to DF. Some author may refer that these two sides are congruent. Okay, that means equal only. Okay, then these two sides are congruent and we have the side BC is greater than EF. BC is greater than EF. Then from that we can imply that the angle opposite to the greater side will be the greater angle when compared to the angle opposite to the smaller side. That is it. So based on that we have some examples here. That is what in page number 313 we have seen. Okay. Now look at the first question. In that, this like one figure is there. This like one figure is there. In that, we have angle 1, angle 2, and these two sides are equal. And this side and this side is equal. The measure of the sides are given 29 and 31 respectively. Now there are two triangles in which we have the two sides congruent to each other. Okay, and we have one side measurements we know. Now the question is to compare the measure of angle 1 and angle 2. Shall we use the Hinge theorem or the converse of the Hinge theorem? Converse, it's not congruence. Converse. Okay, so based on the converse, see we have this angle 31 is greater than 29, right? So by converse of Hinge theorem, the angle opposite to the larger side, angle 2 will be greater than angle 1. That is it. Okay. And then look at the next question, 13th one. Shall I erase this? Have you marked this? Okay. Shall I erase this side? Oh, okay. And the second example, like question number 13, it is. That's it. Okay. So triangle MNL and the triangle DEF we have the sides ML is equal to ED and the side LN is equals to DF and 3325. This side is 33. Then how you can say the measure of angle L and angle D? How you can compare? Shall you use the Hinge theorem or the converse of this? See, two sides congruent. These two sides measurement we have. Which is greater? 33 is greater. Okay. Then the angle opposite to 33 is what? Angle L. Okay. So L and D greater or less than? You couldn't get it, do you? See, we have two sides equal, man. Okay. And then this is the included angle. So we need to compare these two. Which is greater, which is lesser. The converse of Hinge theorem states what? Greater side opposite angle is greater. That is it. Greater side opposite angle is what? Angle. Angle L. The angle opposite to the greater side is angle L. Is it? Okay, then L is greater than angle D. Okay. Got it? We couldn't get this. I can sense it. We'll see the next example. Like the question number 14. Here angle 1, here angle 2, and then here 14, here 8, the measurement. Okay. Now compare angle 1 and 2. See, there are two triangles you should look for. This triangle and this other half of the triangle. In that we need two equal sides. Well, we have only one equal sides. What about this side? Is it equal for both triangle or not? Yes. So it is common. Equal. Congruent. Okay. Then 1 and 2. How you can compare? Which is greater, which is lesser? Tell me. Yes. Good. You got the point. Is it? Nice. And then using Hinge theorem and its converse, describe the restriction on the values of the variable. See, restriction means here we have that inequality, right? That is what they ask, like restrictions. Got it? Now, shall I erase this?